In this transmission network example, we will look at the quasi-dynamic simulation functionality. The project should have study case quasi-dynamic simulation active, together with the base scenario. Note also that there is a network variation called HVDC link. To start with, this variation is not activated. The purpose of quasi-dynamic simulation is to allow load flow analysis of a network over a period of time. For example, in order to study the network under different demand conditions. In this particular model, the loads and generators have been associated with characteristics to reflect the seasonal and daily demand variation and the variability of wind and solar generation. Here is the profile applied to loads to reflect typical winter weekday demand. We will first select the quasi-dynamic simulation toolbar. Before setting up the simulation, we can define which variables we want to record using this button. Certain variables are recorded by default, for example, voltages at terminals. For this exercise, we will just choose these defaults. Using this button, the simulation options can be selected. The time step size can be set to a range of different units. We will use hours. The time period can also be set to a standard unit such as a month, or defined by the user. We will look at just one day. We press execute to start the simulation. Reports can be run using this button. For example, a report on voltages can be made. It is possible to see where the low and high voltages occur, and at what point in the day. We can see that the lowest voltages on the transmission network are in the NW03 substation. The voltages at one or more busbars can be plotted using this plot function. We will select the relevant busbar. And the associated variable. Then the plot can be generated. It can be seen how the voltage varies, being lowest when the system demand is high. We will now run a report to show the loadings on the network elements. We can see that none of the elements exceeds its rating during the course of the day. However, in reality a network will have planned outages throughout the year. Returning to the simulation options, we see that there is a page called Maintenance, where an option can be selected to consider planned outages when running the simulation. In this example, just one outage is defined, on one of the Western interconnector circuits. If this is marked in graphic, we can see that this outage may result in overloading on a parallel circuit. The quasi-dynamic simulation and report are now rerun to check this. The circuit is now heavily overloaded at the time of peak demand. To manage this loading, it would be better if more power would flow through the northeast-southwest interconnector. We will now look at a scenario where this line has been replaced by an HVDC link which can then be controlled to manage the power flows. The HVDC link variation is activated, together with the associated scenario. If we right-click on the HVDC link, we can look at the model in some detail. Here is where we can define the load sharing, using active power participation. We will select the boundary between the northwest and southwest. A participation factor of 1 is set, which means that the HVDC link will carry the same active power as the circuits across this boundary. We can see this if a load flow is run. Rerunning the simulation, it is seen that the worst loading is reduced. The sharing factor can be increased so that no lines are overloaded at any point in the day.